We saw what happens when we took a look at the graph of f of x equals x squared minus 9 over the quantity x minus 3. What happens to the function if we look specifically much closer, like we really get in hundredths of units away from the actual value of x equals 3? We can figure all this out, but we have to plug 2.99 into that function, and that can get a little hairy as far as the decimals are concerned. Let's have the calculator do the work for us. So if we take out our graphing calculator, okay, and we're going to, let me get the glare off there a second, hold on, there we go, that's a little bit better. We're going to, come on, there it is. We're going to hit y equals to start our equation editor, and we want to put our function in. To get a fraction bar, alpha y equals, and option number 1 is a fraction. And then we can put x squared minus 9 in the numerator, push down, x minus 3 in the denominator. We'll hit enter. We want to look at this table right here, and in order to do that we need to set up the table. So you can see that we're starting our table at the x value of 2.96. We need to tell the calculator about this. So notice how it says table set in blue right there. We're going to hit second and then that table set button, and immediately we're asked when should the table start. So we can type in 2.96. Then we want to know how should the change grow as far as the table is concerned, or delta table if you will. Well, we're going up by 100th of a value each time. So we're going to have 0.01 per 100. And we can leave the independent variables on auto. Now it's time to actually look at our table. So the table is right there in blue. So we're going to hit second and then that button for table, and here it appears. And we now have the values to fill in on our table. So we see that at 2.96 the function's value is 5.96. We can disregard the zeros there. 5.96. At x equals 2.97, the function is 5.97. Okay, and that's going to continue onward. I'm going to move the calculator out of the way, but you have it in front of you as well. 5.98, 5.99. Notice there was an error. Let me bring it back in for a second. There was in fact an error at x equals 3 because it's not part of our domain. But after that we have 6.01, 6.02, 6.03, so on and so forth. Okay, let me get those in as well. Okay, so just as up on the graph, as we were kind of tracing along from both sides towards x equals 3, we saw that the graph was leveling off. Our fingers were merging together, and they were merging together at the vertical value of 6. Now we're getting a real close look. We're not just a couple units away from 3. We're hundredths of units away from 3. And if we kind of look at the numbers from both sides, we see that the numbers are converging, and specifically they are converging right at 6. So since the numbers from the left of the function, as we get really close, or x gets really close to 3, are heading towards 6. And as we approach x equals 3 from the right, our values of the function are also approaching 6. Seems to show there that the function is heading towards that value of y equals 6. That is our limit.